Okay, this is module 7, and in this module, we are going to look at two main metabolic pathways, photosynthesis and the cellular respiration. So first of all, a few concepts. Metabolism. So everybody knows metabolism. A lot of people say, oh, my metabolism is very fast, so I don't gain weight. So what is metabolism? That's the total of all chemical reactions carried out by an organism. So every single chemical reaction going on in your body, that's part of your metabolism. For instance, when you drink milk, we talk about the milk sugar, lactose, right? And if you are not lactose intolerant, that means you have the enzyme lactase that can break down lactose to monosaccharide. So the process of breaking down lactose to smaller sugars, that's part of your metabolism. There are two groups of reactions in metabolism. The first one is anabolic. So anabolic reactions include all the reactions where more complex molecules are formed from simpler molecules. So for example, synthesis of sucrose from glucose and fructose. So if you remember glucose and fructose, there you go, I didn't draw it very well. They're monosaccharides, and then when you link them together, that produces sucrose, a disaccharide. Okay, so sucrose is just the regular sugar that you use at home or at a coffee shop when you add sugar to your coffee. Okay, all the anabolic reactions require energy input, right? When you build something, that requires energy, because when you form these larger, more complex molecules, the energy that you invest will be stored in the chemical bonds. Okay. The second group, let me close this. Okay. The second type of reactions is called a catabolic. Okay. So catabolic reactions are, pretty much the opposite of anabolic reactions, where more complex molecules are broken down to simpler ones. So now you're taking things apart. So again, the example would be when you break down sucrose into glucose and fructose. Okay, so in catabolic reactions, energy is released because when we break down a chemical bond, I think we mentioned this before, when you break down the chemical bond, the energy release, the energy stored in the chemical bond will be released. Okay, so usually catabolic reactions will release energy, and your body can capture some of the energy released, and you can make things like ATP, the energy currency. So basically you store energy in ATP for future use. All right, now here's a question. What about photosynthesis and cellular respiration? Are they anabolic or catabolic? So after we go through these two types of metabolism, metabolic pathways, you should be able to answer this question. Okay? The metabolic pathways that we're going to talk about in this chapter involve a lot of oxidation and reduction. So collectively, they're called redox reactions. Okay, so what is oxidation? Oxidation means something loses electrons and the hydrogen atom. Okay, so that means that this molecule is oxidized. Again, when something is oxidized, its electrons or hydrogen are lost. Okay, now in the opposite, reduction means something gains electrons and hydrogen atoms. Okay, so we're gonna say that this molecule is reduced because this molecule gains electrons and hydrogen atom. Okay, now it takes a while to get used to. So besides oxidation, reduction, there's another thing that I need you to remember. So the oxidized molecule, okay, remember, if the molecule loses electrons and hydrogen atom, it's oxidized, right? But relative to the other molecule, this molecule will be the reducing agent because it's reducing the other molecule that takes away the electrons. All right, and then the reduced molecule, the molecule that gains electrons and hydrogen atom, is going to be the oxidizing reagent because it oxidizes the other molecule. All right, there's a term, a lot of times you will see protons Now, we mentioned this term when we talk about the structure of an atom. Okay. Now, a lot of times people would call hydrogen ion protons. Okay, because remember, hydrogen ion only has one proton, and one electron, right? So the hydrogen ion has already lost that one electron. So what's left is just one proton. Okay, so that's why sometimes we call hydrogen ion the proton. Now make sure you don't confuse protons with the photons. So photons are light particles that carry a lot of energy. So photo means light. So if you can remember that, then you know what photons are. Okay, so let's do a quick practice with this chemical reaction. So we have magnesium, we have carbon dioxide, and then we have magnesium oxide and then carbon. So in this reaction, to make it easier, I've given you these numbers so you can kind of decide which one is oxidized, which one is reduced, or it doesn't change at all. Okay, so I'll give you a few seconds. Okay, so magnesium. So in the end, magnesium carries positive charge, right? So that means it has already lost 2 electrons. So magnesium is oxidized. So it's oxidized. Now, magnesium reduces the other molecule, right? Because it passes its electrons to the other molecule. So magnesium is considered a reducing agent because it reduces the other molecule. All right, now how about carbon? So you can tell from +4 to 0, that means carbon gains electrons, right? 4 electrons. So carbon is reduced because it gains 4 electrons. Now, on the other hand, carbon oxidizes magnesium. So carbon is the oxidizing agent in this chemical reaction. All right, now oxygen, you can see this doesn't change, right? It's the same number, so there's no change for oxygen. All right. Okay, now when we talk about organic molecules, especially those carbon-containing molecules, sometimes it's not a complete electron transfer. It's more about the change in electron density. Okay, so change in electron density. Remember, we talk about the different types of chemical bond. So usually these carbon-containing organic molecules, they share the electrons. They don't have complete electron transfer, they share them. So in redox reactions, it's the change in electron density for those atoms, not a complete electron transfer. All right, now it's kind of hard to tell the change in electron density, right? Because now you don't have these numbers. So what you can do is you can use the transfer of hydrogen to identify which one is oxidized and which one is reduced. All right, so let's practice with this chemical reaction. So this is a photosynthesis reaction, which we're going to see a lot. Now, this form is a little special because it didn't cancel out the water. So most of the times you will see reaction, the most common one you see is 6 carbon dioxide, and this is 6 water molecules because it cancels out. And then there's nothing on the other side. Okay, so 6 carbon dioxide, 6 water, glucose, and oxygen. Okay, now, so we're going to look at carbon dioxide and then water. So which one is reduced and which one is oxidized? Again, I'm going to give you a few seconds to decide. Okay, so let's look at carbon. So in carbon dioxide, you do not have hydrogen, right? So no hydrogen present. But the product, which is glucose, you can see carbon has gained hydrogen, right? So when you gain hydrogen, the molecule is reduced, right? So it's reduced. There we go. Now let's look at water. So water, you start with hydrogen, right? Hydrogen in water molecule. And then in the end, you get oxygen. There's no hydrogen. So that means water loses hydrogen, so water is oxidized, and more specifically it's really the oxygen that's oxidized. All right, now can you tell me in this chemical reaction which one is the reducing agent and which one's the oxidizing agent? Okay, so the molecule that's reduced is the oxidizing agent. And then the molecule that's oxidized, that's the reducing agent. Okay. Oh, there's one more thing I forgot to mention here. So in many metabolic reactions, we need to have something, some molecules to carry the electrons, to pass the electrons through the pathway. Because you can see from this photosynthesis reaction, you have the change in electron density, right? So you're kind of passing the electrons. So usually we will have some electron carriers in those pathways to kind of temporarily carry the electrons. And then the ones that we are going to see in this chapter is going to be NADH and NADH and NAD plus. Okay, so that's one group. So it's just one molecule in different forms. One is reduced, one is reduced with electrons, and then the other form is without electrons, oxidized. And then the other one is FAD and FADH. Sorry, FADH2. Okay, so NAD plus, that's the oxidized form. Okay, so it's not carrying any electrons currently. And then when you pass the electrons and the hydrogen atom to NAD plus, it becomes NADH. So now it's reduced, and it's currently carrying electrons. All right, now FAD, FADH2. So FAD, see, without the hydrogen atoms, right? So FAD is the oxidized form, and it's not carrying electron. And then FADH2, that's the reduced form, and then it carries 2 electrons. Okay, so carries electrons. Okay, all right.